Okay, so let's say we have a uniformly charged sphere of radius r, and we fill it with charge density rho star. So let's find the electric potential at some r value outside the sphere, and let's find the electric potential at some value inside the sphere. So if we have r is greater than capital R, then, well, it could also be equal to it, but greater than or equal to capital R. Then we need to integrate the electric field. So we need the electric field from infinity all the way to wherever we want to find the electric potential. And so we use Gauss's law. So Gauss's law involves spheres. So left-hand side is E times 4 pi times the radius of that sphere, the Gaussian surface. And all the charge, of course, would be inside of these spheres, such that this is true, and that would be rho star times the volume. So it's 4/3 pi capital R cubed, and we divide that by epsilon naught, and that gets us the electric field outside the sphere as rho star R cubed over 3 epsilon naught R squared, and we have an R hat. And so the electric potential V minus V infinity is equal to minus, we have to integrate that expression, rho star capital R cubed, which is a constant, over 3 epsilon naught R squared, dr. Most of these are constants. And that gets us, right, from infinity to r. Maybe we should have a prime here, doesn't matter. This gets us rho star R cubed over 3 epsilon naught little r. Okay, so that's the electric potential at some r value greater than or equal to the sphere. So if that's a sphere, then this becomes r squared. Now, what about the electric potential inside the sphere? So in that case, we need the electric field inside the sphere. So this is for r greater than that, and now we want for r less than capital R. Gauss's law reads E times 4 pi R squared, where this R satisfies that. So it's an infinite collection of imaginary spheres inside the sphere of radius capital R, and the right-hand side is we need to use the charge density to find how much charge we have. So it depends on how large our sphere is. So it's 4 pi little r cubed over epsilon naught. That gets us an electric field, which is rho star little r. Of course, we have an r hat over 3 epsilon naught. And that's the thing we need to integrate. So the electric field, the electric potential V minus V infinity, right, 0 at V infinity, is equal to minus the integral. We have to go from infinity all the way into the sphere. And so we go first all the way to R, to the sphere surface. So here I'm writing explicitly this expression. Then we have to continue integrating from capital R to R, such that this condition is satisfied. And that gets us, outside, we have rho star R squared over 3 epsilon naught. And then we have this other calculation to do. So we're using this electric field. So it's rho star little r over 3 epsilon naught dr, and that gets us rho star capital R squared over 3 epsilon naught minus rho star over 6 epsilon naught r squared, little r squared minus capital R squared. And we can simplify that to rho star over 2 epsilon naught capital R squared minus little r squared over 3.